The first thing we're going to do then is, in terms of the lesson for today, the main part, is just go over a little reminder of one-tailed tests. So marking back some of the work this morning that you did from Tuesday, just remember that it's important that you put that context when you do the questions, if there is a context. So for example, question 8 that you did on Tuesday, there was a context, make sure that you put it. So make sure you always write your hypotheses in distribution, work out your probability based on your sample, compare that with your significance level. And the key thing here is, if that probability is less than your significance level, that's when you reject H0. If something's highly unlikely, there's enough evidence to suggest there has been some, there's been a decrease or there's been an increase in the originally stated probability. So really the only difference for the two-tailed test is when we write our alternative hypothesis, we're going to use the not equal to sign. Okay, so rather than use a greater than or less than sign for our alternative hypothesis, we want to use the not equal to sign. We also need to remember that when we're doing a two-tailed hypothesis test, we want to look out for words such as change or different. If it says increase or decrease, then it's going to be a one-tailed test. You're only looking at the change in one direction. If it's talking about change or difference, then it's going to be a two-tailed test. One thing I didn't write down here is also for a two-tailed test, we want to half, and it's actually a really important point, we want to half the significance level. Okay, so for a two-tailed test, because we're looking at the change in either direction, we split that chance of being wrong into both ends. What I mean is, you give yourself, if it's 5% significance level, you give yourself a 2.5% chance to be wrong at the lower end, a 2.5% chance to be wrong at the higher end. First example then, which is, say, both of these examples can be two-tailed tests this morning. Peppered moths occur in two varieties, light and dark, in the ratio of 3 to 1. And what that means is, for every 3 light moths, there's 1 dark moth. So you'd have 3/4 are light and 1/4 are dark. The biologist believes that the proportion of dark moths change. So that's that key word there, change, that implies it's a two-tailed test, not a one-tailed test, with certain types of atmospheric pollution. In particular location, she takes a sample of 15 moths and observes that 7 are dark. So we're going to test the claim at the 10% significance level, and of course we state our hypotheses. So our null hypothesis is the probability that you find a dark peppered moth is 1/4. Alternatively, I could do this problem for the light moths instead. So I could do probability is 3/4 if I look at the light ones. But because in the question I'm told that 7 are dark, I'm just going to keep it with the dark moths here. The alternative hypothesis, we write the probability does not equal 1/4. Okay, so it does not equal 1/4 rather than greater than, less than, which is what we did in Tuesday's lesson. We write our distribution, so it's binomially distributed. Remember, if a question asks you for reasons, make sure you give as many reasons as you can. So things such as there's a fixed number of trials, fixed probability, probability of success or failure, and the probabilities are independent. So in our sample, we take 15 and we've got a probability of 1/4. Now, something additional, what I'm going to do here, what I didn't do on Tuesday, is I'm going to, and you don't have to do this as part of getting your marks, but I think this helps. Doing your hypothesis test, whether you have test the lower tail or the upper tail. Now, the expected number, all I have to do is just times the number of trials by the probability. What this means is, if I take a sample of 15 moths, if 1/4 of them are supposedly dark, I would expect to find 3.75 of the dark moths. Now, obviously, it would actually have to be 4 is what I would most expect. but it just gives me an idea that this is, if the probability truly is a quarter, you would expect around 4 of the moths to be dark. So that what that means is numbers such as 3, 4, and 5 are quite close to what I expect. Those aren't anything of real significance. It's the results that are further away from that 4 is the ones that do give me cause for concern. So because 3.75 is the expected value, I've observed that 7 are dark. What this means is I want to test the upper tail. I found in my sample there's more than I expected. If there were less than I expected, then test the lower tail. So what I do now is I work out what is the probability that 7 or more, because I'm looking at a number that's greater than the expected number. I want to test 7 or more. What's the probability of finding 7 or more in the sample of 15? So you can do a number line again. So I want 7 or more. So what I need to do is do 1 minus the probability of 6 or less. Remember, on your calculator, you can only do, when you put in X, it's that number or less. So I work that out on the calculator, use binomial CD, and I get that it's just above 5% of finding 7 or more. So whilst this probability is low, it's not low enough for me to reject H0. So what I would say is I accept H0 and then say there is insufficient evidence to suggest, and then I'm going to put my context that the proportion of dark moths change based upon atmospheric pollution. Let me know if you've got any questions in the chat. I'll just do a quick check now. If not, we'll move on to our second example and last one for today. And then have a go at the relevant questions. So I'll just give you a chance to ask any questions. And just copy that down. So it's just a dark, that looks, my writing's very poor there. Right, next one then. And our last one today is, over a long period of time, it's been found that in Rico's restaurant, the ratio of non-vegetarian to vegetarian meals is 2:1. Okay, so 2/3 non-vegetarian to 1/3 vegetarian. In Manuel's restaurant, in a random sample of 10 people ordering meals, 1 ordered a vegetarian meal. Using a 5% level of significance, test whether or not the proportion of people eating vegetarian meals in Manuel's restaurant is different to that in Enrico's restaurant. One thing I just want to point out in the last question, just in case it didn't make it clear, is it was a 10% level of significance. When I was testing it, I had to half that, remember, because it's a two-tailed test. Just want to make that clear where that 5% came from. It's because I have to half the significance level in a two-tailed test. Right, back to this question then. So we'll start off by writing down our hypothesis, as we always do. So the probability someone orders a vegetarian meal in Enrico's restaurant is 1/3. We're going to see if it's different. So we're going to see if in our sample of 10, it's not 1/3. So our distribution is binomial. N is 10, there's 10 in our sample. And the probability, remember, this probability is always the same as your null hypothesis probability. So how many would we expect if this is true? how many would we expect to order a vegetarian meal in Manuel's restaurant? So leave that question in chat. Okay, Sydney says 3. Yeah, okay, so 3 is good. So we do 10 times a third, we get 3.33. So yeah, in terms of, because we've got discrete data, we'd expect 3. So it's good to put that 3.33 there, because then we know, are we testing the lower tail or the upper tail? And we know that 1 is in that lower tail. Okay, we find 1 in our sample, so it means we need to use less than or equal to when we do our sample. So we work out the probability that we find 1 or less in a sample of 10 with a probability of a third, and we get 0.104 when we do so. We then compare this to half the significance level. So the significance level is 5%, but we want to look at half of this. So we notice that 10.4% is greater than 2.5%. So what we have to do is we have to accept H0, and we'd say that there is insufficient evidence. So even though 1 is lower than we expect, 10% of the time it will happen that if something has a third chance, 1 in 3 chance of happening, that you will just get 1 out of 10 in your sample. I'm kind of doing things in shorthand way at the end. But as long as we've got that context there at the end, that's the most important thing. For anyone watching this so on the catch-up or YouTube or stream later on, apologies that I missed out the I only started recording after the start question. So let me know if there's any problems with that start question. Make sure you do the start questions. They're really important. Really kind of preps you on different exam topics, and that's what you're going to face at the end of the day in the exam. It's going to be, it's not just going to be hypothesis testing. It's going to be a range of different topics. So that's pretty much concludes the two-tailed test. What we're going to do in Friday's lesson is we're going to look at critical regions, a bit like we've done before, and it's either a different way that you can do a hypothesis test, but sometimes the question might just ask you to state the critical region, or the question might give you the critical region, then you've got to work back from that. So it's still important that you can do hypothesis tests this way when you're given a number and you just work out the probability of that, or sometimes you have to work out the critical region, which is what we'll look at on Friday. But have a look at the assignment questions, work through those, let me know if there's any problems. Make sure you put in that context. Make sure you're always writing your hypotheses at the start. And see you back here on Friday for critical regions. Let me know if there's any questions you've got. Please do ask as many as possible. When doing these questions, feel free to ask us. Don't just copy from the answers. Ask us lots of questions. Let us know if you're stuck or if you've got any issues. If it's not any more questions, I'll stop recording here.